All right, here's our lesson 2.1 on graphing absolute value functions. So a few things I want to remind you of before we get started. Absolute value, just by definition, is the distance between a number and 0. So it's always positive because distance is always positive. And we write it using the 2 vertical bars. So just make sure that you have that written in your notes, that definition and that notation for yourself. And then if I go ahead and remind you what the basic absolute value graph looks like. Now the basic graph for any function is going to be called its parent function. So you need to write that down. A parent function is like the most basic version of any graph. So if I'm going to show you the parent function of the absolute value function, so that's f of x equals absolute value of x. The parent function starts at 0, 0. And has the most basic slope that you can have, which is up 1 over 1. And remember that absolute value, we remember that that is going to make this perfect V. That's how we remember that. So I'm just going to go up 1 to the right 1, up 1 to the right 1, 1 to the right 1. And that's going to continue going forever in that direction. And then the same thing on the left side, up 1 and to the left 1, because remember it has to be positive all the time. So we're going to get a graph that looks like this. So this is our example of our parent function. And then the only thing you need to remember are our transformations. So remember our lovely little dance, and you can write this down on your notes if you need to. Anything that happens on the inside is going to be left and right or horizontal, and it's going to be opposite. Anything that's happening on the outside is going to be up and down or vertical, and it's going to be the same. All right, so those are my transformation rules written out. You may have written that a different way. The other 2 things I want to remind you about are that multiplication is going to change the slope, and we'll talk about exactly what that looks like. And then addition subtraction changes the vertex, and the vertex is just the starting point, wherever that may be. All right, so we have 2 examples of each. We're going to do 2 examples of graphing and then 2 examples of writing. So this first one they've actually already done for us, but I just want to explain where everything is coming from. So we're looking at the example A here. The first thing that I do is find the vertex, which means I'm looking for this addition subtraction part. And I know the vertex inside's the opposite, so that -5 becomes +5, and outside stays the same, so that -2 stays a -2. Notice that on my graph, that is the point that is my vertex, 5, -2. And then I told you that multiplication is going to change the slope. So this multiplication on the outside here, is going to change the slope. It's going to be vertical because it's on the outside, and it's going to stay the same. So remember, the traditional slope was 1 over 1, and this is going to change the vertical part, which is the rise part on the top. I should write that a little bit better, rise part. So that means this slope is now going to be 4 over 1. So if we count from this original point, this original vertex, if I count up 4, 1, 2, 3, 4, to the right one and to the left one, that's what's going to create that V shape for my absolute value. So let's look at another example. We're actually going to work this one out together. And this is example B. So again, the first thing I want to do is find my vertex. So I'm going to name my vertex. Inside's the opposite, that's -3. Outside's the same, that's +1. So I'm going to go ahead and graph that. Let's see. All right, and now we need to deal with the slope. So this time, my slope is going to be on the inside, which means I'm affecting the horizontal, and I need to do the opposite. Okay, so that means I have this 1/2. I need to do the opposite of that, which means the slope I'm going to be using has to do with 2, right? We do the reciprocal. That negative, we've talked about, the negative on the inside is going to be a horizontal reflection, which means I'm going to be reflecting from left to right or across the y-axis. So if you think about that, this V shape, if I reflect that across the y-axis, isn't really going to change anything. It's still just going to flip onto itself and be the same direction. Whereas if I reflected across the x-axis, it would have changed the V to open downward. All right, so if we get back to the slope, remember our normal slope again, if we do rise over run, is going to be 1 over 1. So this time I'm going to change the horizontal component, which is that run component, to 2. So my slope is going to be 1 over 2. And I know it seems like it already said that, but we'll talk about an instance when this gets a little bit different. It doesn't quite work that simply. So I'm going to count that slope. Rise 1, run 2. So I'm going to rise 1 from where I was, run 2. I'm going to do that again just to give myself another point to graph. And then the same on the other side. Ooh, if I could count correctly, rise 1, run 2 backwards, rise 1, run 2 to the left. And that's going to create this V shape, which is definitely wider than it was before. Or that's an example of a horizontal stretch, which is exactly what we said that 1/2 on the inside would mean. All right, so here's our last set of examples for this video, and that's writing functions from the graph. So they're giving us the graph, and they're going to ask us to write an equation. Now, they ask us to write in the directions to write an equation in this form, and that looks, to me, that looks messy. There's a whole lot of variables going on there, a whole lot of letters, but it's really not as bad as it looks. All right, so the first thing we did when we graphed was we used the vertex. So I'm going to go ahead and name my vertex, which I see on the graph is at 2, 5. So I'm going to go ahead and use that in my function. Remember, the vertex is this addition or subtraction piece. So I know that my function, g of x, is going to look like, I don't know if there's a number on the outside or the inside yet. I know that there's bars. I know this inside piece needs to be the opposite, so that's positive 2. It's going to say x minus 2. And then on the outside, it's positive 5, which is the same, so it's going to stay plus 5. All right, that's how we do the vertex. Now we need to determine the slope, and they give us a hint. They say that a equals 1, which means this outside number is just a 1, or we don't even really have to write it at all if it's just 1. That means that I'm looking for a horizontal slope. I'm trying to determine, is there a horizontal change going on here? So if I look at my slope, I notice that I'm going up 1, but horizontally I'm going to the right. Let's see, this is counting by 2, so that's actually right 4. Which is going to make that on the inside 1/4. And we do want to use parentheses just like they show to indicate that the slope is separate from the vertex. All right, so let's look at a different example. All right, so this time we're going to do something very similar. I still want to start with the vertex and go ahead and name that. I see my vertex is 1, 6. And then they also give me this information that b equals 1. So I know this time if b equals 1 right here, then this is not where the slope is going to be that I'm going to use. I'm actually going to end up putting the slope on the outside. So let me go ahead and simplify what it is I know so far. At this point, I know that g of x equals some number, a, on the outside. The 1/1, that's nothing where the b spot is. So that's going to be absolute value of inside's the opposite, so that's going to be x minus 1, since 1 is positive currently. And then outside's the same, so plus 6. So now the only part I have left to fill in is that slope in the beginning. So now I'm just going to go and count what this slope is. And from this first point, let's see, between those 2 points, now you do want to start at the vertex. I'm going to go down 3, and to the left 1, and to the right 1. So that's -3/1, which is the same as just -3. So my slope here is going to be -3, and there is my function. G of x equals -3, absolute value x minus 1, plus 6. Now you may need to rewatch those last 2 examples, put a star next to anything you want to ask about, or maybe do some more practice problems together before we start your assignment in class.